Greetings everyone, my name is Mkhwanazi from Northwest University in South Africa. Today I'm excited to present a short paper titled The Future of News Recommendation, a blend of user preferences, content analysis and social signal, and this paper is written under the supervision of Prof. Ezugwu. So about the content of this presentation, I will have introduction where I will give an overview of the problem and motivation, personalized news recommendation, an overview of personalized news recommender system, and I will highlight different techniques employed. Aim of the paper, where I will clearly state the contribution intended with this paper. Then I will go to methodology, where I will discuss method for system development. This includes data acquisition, data processing, system implementation, and I will go to results and discussion, where I will present evaluation metrics and discuss and analyze the results. And finally, I will have conclusion and future works, where I will recap the study and propose the future research avenues. So, a brief background or simply the motivation of this study. It is evident that the advancements of technology has changed almost everything we know. This includes the way we obtain noteworthy information such as news, where news production companies publish a massive number of articles every day and almost every minute. While this may be advantageous for news production companies, from the user perspective it feels like a nightmare, since the majority of these news items are not filtered. A newsreader must browse through these articles to find a relevant news item. Instead of working in favor of the user, this digitalization introduces information overload. So, the so-called dilemma of information overload and the paradigm of choice call for personalized news recommendation systems. So these systems recommend news based on user personalized interest captured from the readership history. This information is collected as implicit ratings as opposed to explicit ratings commonly found in websites or e-commerce platforms. Such systems have proven to be highly effective in addressing information overload and enhancing the user experience when it comes to online news reading. Types of recommender systems. So in literature, we have three types of recommender systems in view. The first one is the collaborative filtering systems, where in news context, the news item is recommended based on other similar user interest. An example in this, if you like similar news items in the past, and I like a new news item now, that item will be recommended to you since it has been established that we tend to like similar stuff. This can be in two ways, either item-based or user-based, where the former utilizes the similarities between items and the latter utilizes the similarities based on users. So the similarities are often calculated through Poisson correlation or cosine similarities. So this technique is commonly associated with severe cross-start problems where new news articles cannot be recommended as no user has liked them before, and the new user cannot get recommendation as there's those similar users yet, and data sparsity where there's a few interaction around an article. So secondly, we have content-based filtering, which recommend news items based on content similarities. This approach uses discrete features such as the article author, its content, and so on. So these features are used to calculate the similarities with other articles. These approaches suffer less from the aforementioned problems of collaborative filtering and can even recommend news item to user with unique tests. However, this approach has a tendency of over-specializing by recommending two similar items and require intense computational resources to calculate the feature extraction using the TF-IDF or the word-to-vec. So finally, we have the hybrid filtering system, which combines the two approaches into one system, leveraging the advantages of the system and ensuring that it doesn't use their weaknesses. So for the aim of the paper, in this study, we aim to present a personalized news recommendation system based on hybrid filtering approach. The system incorporates social media comments to address the issues, the common issues such as data sparsity, the cold start problem, or over specialization. So the hybrid filtering system will utilize advanced NLP techniques to capture the semantics and the syntax of words. So in terms of methodology, specifically in data acquisition, we have two datasets, namely the mine dataset from Microsoft and the Reddit comments. So the mine dataset is divided into two parts as shown in table 1 and table 2 respectively. The news dataset includes news ID, news category, title, and abstracts which we use. The second part contains the user readership history, where each entry represents the user previous interaction with the news article, and mark good representation with the impression of 1 if the user saw a news and they liked it, and 0 if they saw a news and they didn't like it. That is in table 2. So the second dataset under consideration is the Reddit dataset, which includes the unique user IDs, comment, and the category to which the comment belongs, as shown in table 3. Finally, we have table 4, which displays the readership history represented as 1 or -1. So this dataset is based on table number 2. This dataset is also utilized for cosine similarities calculation and system evaluation. So based on the data that we are able to acquire, we have to clean it, and to do that, we use the NTK library, which has several built-in functions. So as you can see in figure 1, which just gave us a pipeline of the preprocessing method that we use. The first part was to remove the punctuation, We did data tokenization just to change a sentence into two singular words. We have to change the words, all the words into lowercase. We have to remove the stop words, the most occurring words. And we also did word limmatization just to change a word from its plural form maybe into singular form, such as changing runs into run, changing running to run, or something like that. We also remove the short words, and after that we're able to reconstruct the sentence so that we'll be able to get the semantics around it. So after we're able to get our data, after the preprocessing step, we have to create our system, which was a collaborative system, the content-based system, and the hybrid system. So the collaborative system, we use the user commands and also the readership history just to give us a user model, and that on its own tells us what kind of a user we're dealing with. And from the user model, we're able to create now to calculate the cosine similarities between the user that exists within the database. And from that, we have to recommend the most probable news. So we use the cosine similarities just to know which news to be recommended for a specific user. And after that, we did the content-based approach, which employed the TF IDF to extract the news content feature using the abstract section of the news dataset, emphasizing what is strongly emphasized on each article. And to enhance this process, to capture the semantics and the syntax relationship from different contexts, we train a word-to-vec model using a pre-trained model from Google. So the cosine similarities were then calculated based on the user previously read news articles and those in the database, and we recommended the top 30 news on both systems. So we combine the systems, we combine the cosine similarities that we found for both of these systems just to give us the hybrid system. So the top cosine similarities then were recommended as more of a hybrid system. It gave us an idea of which news article is to be recommended based on these two systems, I can say. So in this section of the paper, the results and discussion, we present the results of our system and compare them to the scores of the implemented system from the Mind Scoreboard dataset, which is available online. So before diving deep, I think it's not worth to mention that evaluating news recommender system is quite a challenging task, particularly because the news items are not explicitly rated and they tend to be dynamic in nature, and it's worse when you're doing it offline. So in terms of our system, we predict news based on user history rather than user explicitly response to a specific news article. Therefore, we use rank-aware evaluation metrics instead of the common metrics like the mean squared error or the F-score. So to be specific, we employed mean average precision and the normalized discontinued community gain to measure the relevance of the top end recommended news. These evaluation metrics rely on the rank values of the news articles in the recommendation list rather than being based on the predictive relevance scores, and are commonly used in recommender system to provide an idea of how well this system tends to perform. Average. So a score of 1 input matrices mean that the top K news item to be evaluated, all the recommended items are those a user clicked in the past, and a score of 0.5 means about 50% of the recommended news are those the user clicked in the past. So let's take a look at table 5 below that shows the system results and those achieved by other systems in the leaderboard score. It is evident that the CPF method performs slightly lower than other methods implemented in both metrics, with the highest score of 0.55 when K is equal to 10 using MAP. We believe this is due to the limited text in the abstract that we use to extract the feature values, and it results a bit lower even to that of CF, which we found it to perform very well, across all the metrics that we have, and even surpass some of the system presented in the scoreboard table, having the highest score of NPCG when K is equal to 10, being kept at 0.58. So we believe that such performance is associated with the fact that we use comments to address some of the common problems associated with this approach, and the user on the go can even get better recommendation even if they are new and they haven't read anything before. So consequently, the hybrid filtering system, which is HF, performed relatively well on this and was able to achieve even better metrics score across all the metrics that we have. And this should be expected as it's just a combination of the two metrics, with NDCG at K is equal to 5 and K is equal to 10. It has been found to perform significantly better than the other systems, and even those in the leaderboard. So as it can be seen on table 5. So this alone can be justified that one can use the hybrid method because it tends to perform very bad. So finally, conclusion and future works. In conclusion, we presented a hybrid filtering system that leveraged word-to-vec and CF, IDF for content-based filtering, incorporating social media content for collaborative filtering, just to address some common issues such as cold start and data sparsity. The system calculates cosine similarities, resulting in a powerful hybrid filtering system, as you can see by the results that we're able to achieve. And for potential avenues for future research, we aim to use live test environments to evaluate our recommender system, mainly because there's a lot of problems that are associated with evaluating a system in an offline manner. And we also plan to use deep learning techniques to learn the news and the user behavior rather than just using the classic methods such as TF and word-to-vec. Thank you very much on that.